Thank you, James. Questions? Peter?
You go a couple of slides back. So, you said the difference is a better measure than the ratio.
Yeah.
But everything hangs on that, right? I mean, it's otherwise, if you go with 5, if you go with the ratio as the measure, then you haven't got any more reason to think there's retrocausation than formal causation.
Correct.
And that that needs a more robust defense.
Yeah, it was a bit quick.
Because if I was going to say intuitively, I'd go with a ratio measure. So how do you defend this?
Okay, I don't have a huge amount to say about this. I mean, I think I gave some reasons for thinking that it's less plausible to think that R is a cause of F than F is a cause of R, just because it's a pretty extreme case of probability raising to take probability from nearly 0 to nearly 1, right? Most causal relations aren't that dramatic. And also, we just don't have we have a negligible, for all practical purposes, negligible probability raising in the opposite direction. How much money you'd bet on a post-selection result is completely unaffected by observing the weak value. Now, of course, you could say, well, is that really right? Isn't it actually really epsilon raised for very small epsilon or something? And I think that's where the subtlety must lie here, right? If we performed, you could say, maybe this is the question that was coming from the right-hand side there, that if you performed n weak measurements and made n very large, eventually the system would count as being disturbed. And so Sandra says no.
They're very shortly described things drops with them.
Okay.
You can make almost none of them.
Okay, good. Then that's good for me. Okay, good. Yeah, okay. So, I mean, what I would say is, in the literature on theories of confirmation and all the rest of it, as you know, there's a lot of discussion about which measure we should use. My understanding is that the centre of gravity of the field goes with this one rather than that one, but that's just sociology, maybe. I don't know. But if you like, well, you could say, well, this is a reason to think that that must be the right one, not this one, because intuitively, I think there's just no reason to believe that I have grounds for thinking that R is a cause of F. I mean, it just doesn't make it any more likely. So why should I care about that ratio being the same? This is what I care about. The difference between the unconditional probability and the conditional probability is as big as it could be. When I learn that F has happened, I learn everything about R. When I learn that R has happened, I learn nothing about F.
We have several fingers on this point. Ruth, you have a finger. Is it the same? Is your finger the same as your hand? I mean, so is the point you want to make now? First of all, do you want to make a point on the present discussion? That's a finger.
Well, I don't know. The big problem is characterizing disturbance without taking into account that when you are measuring a pointer, you are collapsing it, and you have a very big distribution of pointer states, so you have a collapse that is very minimally disturbing of the system, but given that the system is then steered, it's an ordinary EPR kind of situation. The bottom line is, I mean, these are just transition amplitudes.
Ruth,
okay.
If you don't mind, I had you next as the next hand on the queue in any case, and there's some people who want to come in on this particular point. Kay, you had a finger on this point.
You gave those analogies about Simon's birth and his character, and you dismissed them as being not analogous to this. But in dismissing them, I believe that you used the measure 5 as your definition as your measure of causation and not 7, because in all of those examples 7 is the case, right? I mean the probabilities are both tiny and therefore the difference in them is tiny. Right, so, and the probability of Simon being born, given that his parents married, is still tiny.
Yeah.
So that number is still tiny, and therefore, according to what you're proposing, you wouldn't say that, I mean, you wouldn't be able to dismiss those examples. You're using...
I see what you mean.
You're using
Yeah.
P of F of R over P of F to be your measure of a cause. You're saying that, Simon's parents being born is a cause of Simon being... Simon's parents being married is a cause of Simon being born. It affects it. So you're using the ratio rather than the absolute difference.
Yeah, no, that's a good point.
Those examples.
Yeah, no, that is a good point. So that I'm just sort of picking what I use to argue against it according to the context rather than being consistent, you might think. Yeah. So what you might say then, you're saying that the probability of Simon being born, given that his parents met, is not much difference to the unconditional probability of Simon being born.
Not by that much. I mean,
right? That you're saying it sort of fits this. Yeah. Well, would you say that for all practical purposes, that case is a bit tricky because I don't really know how to think about exactly what it means to say the probability of Simon being born, because if you think Simon means exactly his DNA, and then there's some random element to the way that the different bits of DNA we combine or something there. But if you just take the other cases, in those cases kind of similar. I mean, the probability of being a member of a cabinet is tiny. It's still tiny if you went to an elite public school, but it's significantly, measurably bigger, right? What, sorry?
By what measure?
Well, from a practical point of view, I mean, it would make a difference for practical purposes if something hung on it and someone held a gun on my head and took a gun to my head and said, "No, what do you think? Is this person a member of the cabinet or not?" Right? It would change how I behaved if you told me they'd been to an elite public school. It would make a difference, even though the probabilities are still small. But the whole point in this scenario is it's not supposed to make any practical difference whatsoever to the probability of the post-selection result to find out that you got a result near the weak value. But I mean, let me just say anyway, you may be right, and I should just say this again, but if there's two steps to the argument, and one is that there's a causal structure here, and then step two is what is the causal structure. Now, if you think there's a causal structure, and you don't think it's the retrocausal one, then you have to think that the causation goes the other way. But if you think that's still a story that needs to be told, because we haven't got a story like that. We don't have anything in our formalism or understanding of physics that tells us how that weak measurement result is a cause of the later post-selection result. So if you went for that option, you'd have to talk about that, and that would itself be an interesting discovery about quantum mechanics.
Brian, you had a finger on this.
Yes, thank you. Disregarding measures of confirmation, my sense is lately, to the extent that there's even sort of agreement on that, it's fraying lately, partly in light of Roberto Festa's paper on mathematical properties for confirmation, and there seem to be plausible things you could say to get more or less diametrically opposed qualitative features for measures of confirmation.
Yeah.
So that might make one want to just cling more closely to Bayes' theorem and less to some sort of separately postulated measure of confirmation. Yeah,
okay. I mean, I know there are lots of measures of confirmation in the literature. There's the ratio measure, there's the difference, there's things where you take the logs of things, and there's all sorts of ways of doing it. I feel like I don't want to put my trust in any of that. I would try to think about it without having any theoretical presuppositions. If you thought about pre-theoretically, you think, well, when you tell me that something massively raises the probability of something else, that seems like in absolute numbers, right? Now I learn this thing, this probability goes to be very high from being 0. That's more reliably telling me about a causal connection than telling me that the ratio is big when the numbers are tiny. But I guess I'm just repeating myself. I don't have anything more to say there. I will just say again that, okay, so if you think that the ratio measure is the relevant one, then you're going to think that the weak value result and I keep calling that weak value result, what I mean is just the result being near the weak value is something like is some kind of cause of the post-selection result. And again, then you have to fill that story in because that's not part of our orthodox understanding of the theory or of what's happening in weak measurement.
Dustin, do you have a quick comment on this particular point?
Just something to face point with the example with members of cabinet and so on. You can make those ratios and also this difference was basically arbitrary. We're just enlarging the population and then the percentage of population.
That's true. Yeah.
Cabinet. So I think in the end it's the same because I mean also the weak measurements not that they don't change the probabilities at all. It's just that you can make that change in probabilities arbitrarily small. So in the end, it seems to me to come down to this play with numbers, which can be very different, but both very small and so almost equal to 0. So.
Yeah. Okay. No, that's a good point. So I should have thought. I suppose of being too quick with that. So what you could do is instead of being a member of the cabinet, you could just have being foreign secretary, and then we consider the population could be the whole of the Earth's population across all time, and we could have being foreign secretary in 1990, and yeah, the numbers would be really small, but it would still be. But I suppose I just want to keep coming back to the fact that in every one of these putative counterexamples, what we're given is a causal structure where the later event raises the probability of the earlier event, because the earlier event is a cause of the later one, right? So if you want to say my case is the same as that case, not my case, but this case, if you want to say it's the same as that case, then you're really saying that somehow the weak measurement result causes the post-selection result. So I suppose you could put my argument, rather than calling it an argument for retrocausality, we could call it a dilemma, right? Either retrocausality, or we're owed a completing of the story that explains how weak measurements cause later events to change their probabilities, brings about post-selection outcomes. Change the probability of the post-selection outcome is a cause of the post-selection outcome. Yeah, but either way, there's a causal structure, so something's got to be said.
Okay, let's move on. Ruth.
Yes, I think you're absolutely right that it's a non-trivial question about which direction causality is going in. But if we just look at standard quantum mechanics, where one has an uncritical attitude that causality moves in the usual forward, future directed direction, then there is a straightforward account in terms of transition amplitudes. If you look at each run of the experiment, then you have a preparation state, you have a collapse in the pointer basis, and then that does also collapse the system into a pure state, however large error it might have with respect to the observables of interest. Then you do your final post-selection. There's a series of collapses that in the usual traditional way, where the final result is conditional on the preceding result. And there is a straightforward, consistent account of that. There's nothing really magical going on. I mean, if you look at the weak value as an average, you have to take into account that is coming out of individual runs, each of which behaved in the usual way that standard quantum mechanics says it behaves. I mean, I don't think there's anything missing in that story. Now, again, those transition amplitudes do not in themselves tell you anything about causality. I mean, I agree, that's a non-trivial question. But I think it's kind of misleading or inaccurate to say that if we look at we want to try to conditionalize on initial and final and then make some sort of causal inference, there isn't really anything there that I think allows you to make that sort of inference as more relevant than going the usual forward direction.
Right, but that just can't be right. I mean,
Why not?
if I have a Hamiltonian and I have initial measurement and a final measurement and then a load of measurements in between, then I will change my probabilities for intermediary measurements based on what the Hamiltonian is and what the final measurement outcome is. And if you don't change your probabilities, then I'll win money betting you about what the results of the experiment will be.
Well, maybe you're defining the relevant probabilities differently than what I have in mind. I'm just talking about
Well, just take
transition
the trivial
amplitudes.
case I mentioned before. If the initial measurement is spin up in the x direction, and then I'm taking an intermediary measurement of spin in the z direction,
And you're actually doing
and I
that
say to
measurement?
you, okay, you're only allowed to use information from the past, so what do you bet on the intermediary measurement being up in z?
Are you actually measuring that?
Yeah, we're really measuring it. And you say 50-50, but I know that the final measurement was up in z. And I say 100%, and then I win.
Oh, but those are just epistemic probabilities
No,
based on...
well, that
Well, I'm
corresponds
talking
to the
about-
frequencies of lots of measurements like this, right? I mean, it does change the probabilities, but the transition probabilities for intermediary measurements change if we know the results of later measurements. That's just true. Well, I don't know anything.
Yeah, but, I mean, you can... I'll have another example in my talk. I mean, there's nothing inconsistent
I'm
about
used to that.
giving the argument in the forward direction.
But look, let me just say as well, right, I mean, there's a general point to make here. I think that we were talking like to people about retrocausality, but yesterday, and, Hughes put retrocausality as an option to be considered into the literature some time ago, and we're all here to discuss it. I mean, where's the burden of proof? Why are people so absolutely sure that there isn't retrocausality? I mean, I don't know, but I wouldn't have thought that there would be weird correlations in quantum mechanics, and I wouldn't have thought all sorts of things about the world would turn out to be the way they are. So I think one thing you have to ask about this kind of setup is, well, if this won't convince you of retrocausality, maybe that's because you just have a premise that says all causation is forwards in time, right? Well, then you'll just never be convinced by anything. There'll always be some way to re-describe it. So the question becomes, well, why are you so sure about that? Things are more subtle than we might be given to expect in respect of time symmetry in physics. Maybe there could be
Can I follow?
Causes from the future to the past. I don't know.
I'm sorry, Ruth,
Can I
we've
follow
got
up?
quite a
Because
long
I
queue
don't
of
really think it's
people
fair
who'd like
to
ask questions,
say
so
that
Liv,
when you're looking
you're
at
next,
different
please.
ensembles. Thank you.
That's this first option, incidental correlation,
Yeah.
which of course, if these correlations are accidental, I think we don't need them. But I view this story as really as correlations. In a sense, your example will be in my talk as future affect the past. But when I look on your presentation, I think the story here are correlation. And maybe especially here, it's important to make clear what retrocausation means. From my point of view, causation, I make some action and something changes.
Yeah.
You compare results. Results cannot cause.
Yeah.
I can decide to make measurement or not to make measurement. This might cause something. Here there are some correlations because I decided to make weak measurement. I created some tiny entanglement, and this entanglement is reflected in these unusual correlations, which are more or less kind of one-way correlations because of small numbers and whatever. I think it's really related, the connection, as Faye mentioned, to this classical example of the small probabilities are not so different from this story. So what you would say about causation, from my point of view, you need action and not outcome.
Okay, good. So first of all, just what Faye was saying, but in those cases, you wouldn't deny that the earlier event was a cause of the later event. And if you're in the cases where the cabinet and the public school, Simon's parents, Simon being born, in all those cases there is a cause from the past to the future. Now that's one of the options here, but as I said, you then have to say more about how that works. Right? The second thing I would say is, yeah, I think I take the spirit of your point, that's why I said at the end, I don't want to call it causation, I want to talk about something else like causal dependence or law-like dependence or something like that. And that's precisely not to beg any questions about whether it should be called a full-blown cause. And I think of the EPR case here. I get really cross when people say there's action at a distance, because I say exactly like you, action at a distance is, in that article that was quoted yesterday with Albert says EPR correlations are like a punch being thrown in Maine and a bruise being received in Vermont or something. And you say, no, it's not like that at all. In that, there's an asymmetric causal structure, unambiguous. Punches cause bruises, not the other way around. There's an action, brings about an effect. Right? In the EPR case, you have symmetry. There's no reason to think that this side causes that side rather than the other way around. So it's more like some kind of causal dependence between the outcomes, but not a causal relation from one outcome to the other. And so I would say, well, maybe we just need to broaden our class of what we call, broaden our notions here, right? So we could have cause, but we have something weaker, which we could call causal dependence. And we say, well, what is that? And it's like, well, it's like cause, but it's weaker, it doesn't involve an action, you can't signal with it, or whatever. Take out whatever ingredients are... But it's not just correlation, because it's law-like and causal and robust and projectable. It's not an accident.
It's not an accident. Making quick measurement and finding unusual anomalous result, it changes significantly the chance of causation.
Yeah.
When you say it's changed the ratio, it's still very close to zero, but it's much bigger.
Right, but if it's just whether or not we use the word cause, I don't mind. That would just be a semantic matter. It's not an accidental correlation. It's a law-like, modally projectable correlation but it seems to be from the future to the past rather than from the past to the future. Unless you say R does cause F, but then you have to tell some story about that, as I said. And I should just thank Lev, who graciously allowed me to come in before him, because I was worried that he was going to say what I was saying was wrong, and I wanted to say what I was saying first before he said why it's wrong. And he kindly agreed to swap places in the programme. Sorry, Sandy, do you want to...
Sandy, do you have a finger on this?
Yeah, I don't know how many. Yes, I think it is a continuation of this. There is yet another element that needs to be said. Of course, you can run the quantum mechanics forward and obtain these results, but there is also a question of complexity. If you really want to describe everything with a wave function propagating forward in time and not doing anything else, you need to go through all those very, very complicated interferences that happen in the pointer that somehow give the result of the weak measurement, and it is a whole mess.
No, it isn't.
On the other hand, looking at influences propagating both from the past and from the future, the explanation is much, much simpler. So if you look at the complexity of the explanation, and we tend to think that the simpler explanations are better, then it's a no-brainer.
So I suppose I would just add to that by saying, yeah, and if you just looked at this structure and you didn't know anything about it, you'd say there was a cause from F to R. And so then that's the point about this burden of proof issue, right? What some people would do, nothing will persuade them that there's any cause from the past, from the future from the later to the earlier. But if it does some violence to your background metaphysics or something, maybe that's a reason to count against it. But it seems easier, simpler, prima facie, that's what's happening.
Yeah, if I could just allow myself a very brief finger, I think there are two possibilities here. One, as you say, people could just have a metaphysical picture such that they're not willing to entertain retrocausality. The other is much more like, I think, what Lev's points, that since their intuitive picture of causality is associated with being able to do things with intervention, as so much of the literature these days says, the resistance might be coming from the fact that it doesn't seem like we have a case in which we can intervene on F to influence the probability of R. So that might be the source of the resistance to call it causality.
Right.
Unlike in the cases that I was presenting yesterday, where under those certain conditions, you do have something you can intervene on with which something earlier is necessarily correlated.
Yeah.
So I think that's...
So then it's going to be like the EPR case where you can't control the outcome, so you can't intervene, but there seems to be some kind of...
Yeah, I mean, I think there's another distinction you need to make there, because I think you can have causality without signaling. But in any case, I didn't want to take up too much of the time. We're almost out of time, and Jeremy has been waiting for a very long time. So Jeremy, I give you the last question.
Okay, well, this is a bit open-ended, but I wondered whether it made much difference in your analysis, whether one used conditional probabilities versus conditionals with a probabilistic consequence, or probabilities of a conditional. Because as you know, long ago, in the early 90s, under the influence of Lewis' analysis of causation in terms of counterfactuals, there was a lot of discussion of that. And related to that, your discussion of ensemble and your mention that R and F are time-like related.
Yeah.
Just, and probably this is in your paper in detail, there's a matter of whether to get your 100 Z ups final,
Yeah.
you do a billion all simultaneously, or do you devote a whole week to your experiment so there are many runs such that, you know, so to speak, luckily on Wednesday afternoon, we didn't have to wait.
I think it doesn't matter either way, right?
Sorry?
It doesn't matter either way, I think.
Probably doesn't matter, but if you're going to, so that relates to whether R and F are token or type events, as the philosophers say.
Sure.
So, I'm sorry, there's a couple of slightly open-ended questions, which probably don't make much difference to the debate.
No, I haven't thought about the difference between conditional probability of a conditional, yeah. I have to think about that more, but I don't think it matters whether you have a whole load of systems and then you do them all at once, but I look to the experts to tell me about that. Does it matter when how we make this ensemble?
Well, the cleanest way is that you measure all of them at the same time.
Okay.
We have a spin 100 and then there are no more discussions. It doesn't really
Okay.
Okay, we're out of time.
Thanks
so
very
please
much.
Join me in thank you.